All right. Hi, everyone. Dr. Codd, thanks a lot for having me. Ronnie Calvin, thanks a lot for putting this together. I'm happy to be here. Last time I was in your guys' seats, I think I was taking an exam, so it's a lot better to be on this side of things compared to that. So I'm giving a talk today from idea to publication, which is kind of ironic because I had 0 publications as a medical student, but not in residency. So hopefully you guys can take some of this, apply it to yourselves, and propel forward in your careers. So Dr. Codd mentioned this. This is my educational background. I went to Dickinson. I was actually a reapplicant for medical school. During that time off, I spent it in a translational research lab at New Jersey Medical School, working on diabetic rat colonies. I eventually got into Robert Wood in 2016. I was a successful first-time orthopedic applicant, getting into Monmouth Medical Center, where now I'm a chief resident, and fortunate enough to have matched at MGH next year for shoulder and elbow surgery. Because this is a research talk, here's the publication history. Take note of the time periods where this happened. So I only had 2 publications during my research here at NJMS. While I was in your position as a medical student, I had 0. That's not due to a lack of hunger, work ethic, or what have you. It really was due to a lack of opportunities. I'm sure you guys know you try to start a project with a resident and it really goes nowhere, or there's no projects available. So the same case happened when I got to Monmouth. There's no research infrastructure. It's a small community hospital. So I had 2 options. One was to do nothing and get 0 publications heading into fellowship, or the second was to figure out how to do it myself, which is what I've done. Quick slide on, what's your why? So for me, it was to prove to myself that I can do things. 2, like I said, was to match at a competitive fellowship. 3, which we'll talk about later, and it's what a lot of you are doing with me and some of the connections I've developed, is to build a rapport with people from different institutions, and ultimately it's to pass it on. So people ask why I keep doing this, despite having the numbers that I do, and really I just enjoy it, and giving you guys opportunities that I feel like I didn't have. So here's my formula. It's 4 easy steps. Just try to remember this. We'll go through it throughout this entire presentation as I show you examples, but 1 is identification, feasibility, novelty, and then execution. So for identification, I'm not smart enough to come up with my own ideas. And if I were, I wouldn't be able to determine the methodology that would lead to a publication. Nobody wants to do work and then it not get published. So why not just find something that's been published in a reputable journal, make sure it's novel, and that you can apply it to a specialty of your interest. So for example, I go to PubMed, I do an advanced search by journal. I'll pick usually Journal of Arthroplasty because I'm going into shoulder elbow, and shoulder arthroplasty kind of lags a little bit behind hip and knee. So that was my pursuit. You can use Yellow Journal, JBJS, and even non-orthopedic journals, as you'll see. So take this, for example. This is a 2024 JOA study, early prosthetic hip dislocation. Does the timing of dislocation matter? So the authors want to determine if the acuity of a dislocation episode affects your risk of having the need for revision surgery. So, I mean, that's a catchy title. It seems relevant, particularly with reverse shoulder arthroplasty for fractures. They have a higher dislocation rate. So it's something I'm immediately thinking might be relevant to me. Number 2, like I told you, you have to determine the feasibility of your idea. So what I do is quickly look at the methods within the abstract and determine, is this feasible at my institution, which is Monmouth? So quickly looking at their methods from their abstracts. And by the way, if the methods seem feasible, always go to the full text article and read it more in depth to really double check. But this is a quick overview. So I read their methods and essentially what I determine I need. An administrative database, right? They use this all payer database. I don't have it. If I did, they retrospectively reviewed 45,000 patients. I don't have time for that. And then 3, if I wanted to, I'm not going to do a match cohort statistical analysis because I don't know how. So red flag, we're not doing that. New example. I looked at the American Journal of Sports Medicine, right? The top sports medicine journal in orthopedics. We come across this, transparency matters. Assessing harms reporting compliance in randomized control trials, underpinning the Academy's clinical practice guidelines for ACL injuries. All right, a lot to digest with that title, but it's pretty catchy, right? And it's bold. So essentially, clinical practice guidelines are a set of guidelines for certain interventions, and they're based on evidence that exists. The evidence is in the form of randomized controlled trials. So there's this 18-item checklist, which basically determines whether or not you're adequately reporting adverse events associated with that intervention. So if you're going to establish guidelines, you should report all adverse events. So this study used that checklist to determine percent compliance, right? And it got published in AJSM in 2024. So again, we determine the feasibility by going to the methods of that abstract, and it distills into the fact that we need access to these clinical practice guidelines, and we need access to this harms checklist. Quick Google search takes you to the Academy website. You find the guidelines, which are all listed here by different topic. You go to the methods of that paper. They give you a link where you can find essentially this PDF for the 18-item checklist they used, right? So now I know it's feasible, and now you got to think, how can I apply this to what I'm interested in, which is shoulder? So we go back to the guidelines. We see that there's one for glenohumeral joint osteoarthritis. So, now I'm really excited. All right, so I'm looking up like flights to San Diego. I think I'm going to make an abstract. I think I'm going to present this. I'm planning on doing it and submitting it to JSCS. And that leads to our third point here, which is novelty. All right, so has your idea already been published? And then there you go. So JSCS 2024, they published the exact thing I wanted to do. But patience is a virtue. So here are the successful examples. Assessment of the NIH-supported relative citation ratio as a measure of research productivity among a bunch of academic neurosurgeons. So look, this was a non-ortho journal of neurosurgery, which is big within that particular field. I have no idea what this relative citation ratio is, but everybody cares about research productivity. That's why you're all sitting here. And then you look at their objectives, right, to get more information. So the H index is something we're all semi-familiar with. It's something that's used for academic hiring, promotion. It's a way for people to basically assign a number that tells you how academically productive somebody is. So there's issues with this H index. They're saying it's not field normalized. So you can't take a vascular surgeon and compare it to an orthopedic surgeon using the H index. It's also not time normalized. So surgeons who have been in practice longer will probably have more publications, thus a higher H index. But what if their studies aren't as impactful? So you need an article level metric that basically will be time and field normalized, which is what the NIH released, this relative citation ratio. So you go to their methods, and again, I need access to something called the iCite database, which essentially will give you the relative citation ratio, or RCR, for each surgeon. You need a list of surgeons or faculty, right? So obviously I'm going to find one for shoulder elbow. And then what they did, if you read this, they did subgroup analyses based on sex, career duration, academic rank, et cetera. So we need academic information for each of the faculty members, which is publicly available. So here you go on Google, you type in iCite database, this thing comes up, right? You put the author's name in it, and it spits out number of publications, the RCR, and the weighted RCR, three of their main outcome parameters. Then I go to the ASCS website. I see a list of shoulder elbow fellowship programs with associated faculty members. So you see where this is going. I'm going to do what is the relative citation ratio among ASCS fellowship faculty. All right, that goes to the fourth point. Once you have an idea that you've identified, you've made sure it's feasible, you made sure it's novel, then you got to execute. So what I do is I basically make these Excel sheets. So you see in the left column is the faculty members. Each column thereafter is all the outcome parameters that they looked at, which are variables that can be collected from publicly available sources. And then I assign usually one or two interested students or co-residents or what have you in the paper, and basically ask them to fill this out. We have a phone call, we have a Zoom meeting, whatever it is. So everybody's on the same page and understands. I send them the reference paper so they really get the methods. And then that way you're not doing work that's going to go nowhere, because everybody knows and there's going to be limited mistakes. So once this is going on, it's usually like a 1 to 2 week deadline, for example. I'll be writing the intro and the methods and the abstract. The only thing we need then is the results. Once that comes in, we need the discussion, right? So after a 3-week turnaround time, you get a publication submission. All right, and then you just emulate this over and over and over. So here's an example of the data tables. Basically, you go to that paper, you look at their tables, you create empty ones, and then once all that Excel sheet's filled out, then somebody who's good at stats, which I'm not, usually one of you is somehow. I've got away with doing all this with zero knowledge of statistics. They'll do this, and then that's it. We finish the discussion and sent the paper in. And you can see here, this was truly novel. RCR wasn't introduced in ortho, so we did it for spine, joints, hand, shoulder, elbow, and sports, right? So you guys are really thinking oncology's up for grabs, et cetera. So get on it if you really want to do it. Sorry, let's go forward. Here's another example. So a comparison of matched and unmatched orthopedic surgery residency applicants from 06 to 2014, data using the NRMP. I'm sure all of you have gone to the charting outcomes in the match on Google, right? It gives you the stats for matched and unmatched applicants. This group was smart enough to just show the differences between the two groups and publish it in JBJS, right? The biggest ortho journal within 2017. But what does this tell you? NRMP is publicly available. Has this been done from 2014 present, right? Because you guys all want to know what present day stats are. You go to their methods, all we need is the NRMP data set. We go to Google, we find the charting outcomes in the match, and it literally gives you matched versus unmatched applicants, the N number and the mean values, all for their outcome parameters. And then we publish it. So we basically found the years 2014 to present. We saw that the differences between both cohorts were narrowing, made a catchy title, and then actually compared those differences to the differences in the decade prior. Another example, variation in pediatric orthopedic case volume among residents, an assessment of ACGME case logs. I'm already thinking, as a resident, we have to log every case we do. Case logs are publicly available. Variation is a strong term because anytime you deal with education, you don't really want variation. You want consistency amongst people, right? So there you go, published in Journal of Pediatric Ortho, the biggest orthopedic journal in 2018. So I'm thinking, what do we need? The case log data and unique ideas. Go to Google again, ACGME website, you see that on the right side over here, case log statistical reports. You click on that, it gives you something that looks like this, broken down by year. So you can see that they break it down into areas. So I looked at shoulder and elbow. In the next column, they give you procedure types. All right, so you can see arthroscopy, right? Shoulder arthroscopy is a big thing. And then I'm thinking you can do it for hip, knee, et cetera. They give you the national mean in terms of how many, on average, the graduating residents are performing for that year. And then they'll also, which I don't have here, they'll give you the 10th, 30th, 50th, 70th, and 90th percentile of performing residents. So you can see the number that the 90th percentile is doing versus a 10th. And if you do a ratio, you get a measure of variability that way. Okay, so usually you want it by 1, right? Sometimes these are 10, 11-fold differences. And again, you have your unique ideas, and we do this a bunch of times and get a bunch of publications out of it in big time journals. Here's one more. This is probably the most interesting one. So look at this journal. No one here knows what that is, neither do I. So it doesn't even have to be a reputable journal. Read the title and make sure it's important. Comparing scientific abstracts generated by ChatGPT to real abstracts with detectors and blinded human reviewers. All right, ChatGPT is a huge topic. We all know that its use is increasing. The influence of it on scientific writing is still being explored. So this has already caught my attention. I look at their abstract. What they did was gathered a number of articles randomly selected from the top medical journals based on impact factor. And what they did was they put the article titles within ChatGPT, asking it to produce a scientific abstract. Now you have a list of real and fake abstracts. They put them into a document. They send them to blinded reviewers and ask, are they real? Are they fake? Okay. And then, as you would imagine, humans can't detect it at a high level at all. But if you do the same thing with a ChatGPT detector, they basically get it right a lot of the time. In this article, it was 99.9% of the time. So this has implications for, review process, things like that, because you guys can all send the abstracts you're presenting today to the Academy meeting, and basically ChatGPT could have written it, right? How would they know? So it is important. So what we need, ChatGPT, articles from high-impact ortho journals, and I need blinded reviewers. I went to the PubMed, and nothing like this has been done for ortho. So, I knew this was going to be a big idea. I'm wondering, how can I add a unique spin to this? So even if reviewers get it right, they're like, oh, that was fake. Are they really confident in that decision-making process? So we introduced a Likert scale to assess their confidence with each interpretation. And then what we did was assess the primary reason guiding their assessment of generated text. So if you think this is fake, which of the following describes the most likely reason that you came to that conclusion? And we, unrealistic data, methodology, linguistic style, and then 2 other things that I can't remember. And then our results, shoulder elbow surgeons with collective like 50 years of reviewer experience, only 62% of them identified generated abstracts, meaning that they misclassified 38% of they misclassified 38% of original ones as being fake. So that's a problem. And then we found that correct identification of the AI generated abstracts was due to the presence of unrealistic data and values. I don't know if you guys know anything about a ream and run procedure. What it is you basically, when you do a shoulder replacement, it's like a half a shoulder replacement, essentially. You replace the humeral component, and with the glenoid, you just ream it. You don't put any components in there. If you ask ChatGPT to make this article that was about the ream and run, within their results, they talked about the rate of glenoid loosening. You can't loosen a glenoid component if it's not there. So all 8 of the reviewers found that as a mistake, right? So that finding that the presence of unrealistic data and values is important, and that's a new thing to our study that I knew would make it big. So here's another spinoff of why research is important. I told you I needed blinded reviewers. Who am I going to pull from Monmouth that's in shoulder elbow? We have one shoulder elbow surgeon. So I knew it was going to be a good idea. I used one minor connection I had who has plenty of others. And, now we have some of the top names in shoulder elbow surgery from the top institutions in the country that, by the way, they currently serve as fellowship faculty members. So we timed this up right before my fellowship interviews. Me and Ryan, I think Ryan's here, but yeah, we did that. So now Ryan's benefiting from, connection. So the whole point is, if you have a novel idea, it's feasible, go ahead and do that study, take the initiative, contact the resident thereafter, contact an attending thereafter. And once you get the hang of it, branch out and really find these prominent figures that can help propel your career. So they're Ryan's first author on this paper, published in Arthroscopy 2024. And I couldn't have done literally any of this just by myself. I kind of have the formula, but the team is really what makes it happen. And I was fortunate enough to work with a number of you in the past couple of years, over 30 medical students, over 20 residents, and now 15 plus attendings and counting at multiple institutions. So you guys are all way ahead of the curve since I had 0 as a medical student. So I'm hoping, this formula you guys can use and really do way better things than I've done. So thank you all for having me. Do you have one last thing, connections, equal opportunities. That's what I was going to say. So at Monmouth, we don't have databases. We don't have clinical studies, right? But if you do timely work, it's efficient, it's high quality. And these prominent figures see that time and time again, that you're sending that to them. They're going to then start sending you stuff, right? So here's just a small list of journal chapters, instructional course lectures, yellow journal review articles, things like that have come my way just from being at the right place at the right time. And that's it. So thank you guys very much.
Like, can I ask you a question? You're just I want to give it up to you because we have so many people.
I appreciate it. Thank you very much.
My question is, and it may be hard, but you went from no publications as a medical student to all the way up to 76. What was that first eureka moment? Can you just kind of walk through that, the first 1 or 2? Who kind of extended that hand to get you going?
Yeah, so I have I got into Monmouth, and we can't control the match and outcomes of that nature. So you put a lot of work into something and you might not get outcomes you want. Some people don't match, some fall towards the end of their list, et cetera. When you get to that institution, I love Monmouth, it's a great training program, but there wasn't a research infrastructure. So for me, I was kind of upset at the fact that there wasn't. I also really liked shoulder elbow surgery based on my away rotations. And at that time, we didn't have a shoulder elbow surgeon. So putting those two things together, I thought, is there data out there? I wonder how many cases in shoulder elbow other residents elsewhere are doing, and can that be normalized? So people within different programs all get that, right? That pediatric paper, there shouldn't be variation. It should be across the board. So I somehow went to PubMed and I saw that someone from Brown had published a number of these case log studies, but one hadn't been done for shoulder elbow. So it kind of killed 2 birds with 1 stone. I was able to look at the public data on number of shoulder arthroscopy or revision or replacements being performed, and then was able to look at trends over time with just simple stats, because they give you the mean, the N number, and the standard deviation. Like, there's nothing else to do. So I was able to literally Google descriptive stat calculator and then put it in myself. And then I looked at these trends over 5 years, and that's how I got that Journal of Shoulder Elbow Surgery pub. But the real thing is, I had no idea how to write like you're talking about. So I had emulated the papers that were done. And there's someone, Mariano Menendez, He's currently at UC Davis, spearheading their shoulder elbow department. But when I was a rotating medical student at Tufts, he was a fourth year resident. So I became really great friends with him on that rotation. And he was an IMG, right? 19 IMGs. We did a paper on this, matched over the past 2 decades in orthopedics. So he was one of them. And he did multiple research years at Harvard. He's like a brilliant guy, and he's the man. So we really got along. And then when I was at Monmouth, we kind of lost touch. But then I had this idea, and I knew it would get in, but I didn't know how to write. So I knew with his publication background, he has like 300 something publications, this guy. He went to Rush for shoulder elbow fellowship, everything. So like you guys, you see somebody a couple of years ahead of you, they know how to write, they know the process, you get along with them, you establish these connections. So I sent him the draft. It was terrible. He really just edited it, basically rewrote it. And then through his edits, I learned. And then I did it again and then again. And then that number of edits he would make on my stuff would be almost negligible, to the point where at Tufts, they have more clinical stuff than we do. So he did this similar enterprise that what I'm doing with his co-residents at the time. So when he was at Rush for fellowship, all his residents at Tufts were still doing stuff like this, but they had already gotten into fellowship, so they didn't want to continue the projects. So what they did, because he knew me and my ability to write at that point, they would send me all that stuff. And I would sit there as a second year and wrote 21 papers in a year, but that was all stuff that they had given me. And then I figured, oh, I can just do this myself. I don't really need to rely on other people. And then when he was at Rush, that's when those, big time surgeons have these book chapters, this and that, but he's a fellow. He doesn't want to spend the time to write it, but he had already trained me. So then all the stuff from Rush was coming. And then, Dr. Grant Garrigues is their fellowship director. He would put me on stuff, and then, he would contact the Rothman guy. And, it's like a whole thing that happens, but essentially I utilize the same principles when you guys work with me. We start you off on the data collection. A lot of things that weed people out is the timeliness. You tell someone to get something done in 2 weeks, right? And then you don't hear from them for 3 months. You don't really want to work with somebody like that. That person who's going to get it to you in 2 weeks and be detail oriented, then okay, I can utilize this person. And then you take them from doing the data, right? They've proven themselves at that point. You give them, write the methods, write the results, right? Which is basically verbatim using another paper, right? It's not really like you're doing it on your own much. And then from there, you have them do the intro, the discussion, and then you learn from my edits. And then I still send every paper to Mariano, and he edits it. And then from there, I send it to now my attendings at Harvard that I haven't even met yet, besides the interview day. But we've already sent them like 5 things, so this is how these things work. And then next year I go to fellowship, right? And then you guys work with me. I know the work and quality you do. I get the book chapters, I get the ICLs, I get whatever. I don't want to write them anymore because I'm busy now, but you know what I mean? And then I send them to you, right? And then that's how this whole process with me happens for each of you. So.
Fantastic. So thanks for coming.
Yeah, of course. Thank you, guys.
Thank you very much for the talk, Sly.